always. Now, and again, the biggest part of this is really coming down to factoring. As long as we have it factored and follow the processes we've been doing, everything else falls in line. Because we stopped with this problem here, because we did addition and subtraction when we finished or stopped on Thursday. And again, with addition and subtraction, if the denominators are the same, we add or subtract the numerators. If they're not the same, we need to get them to be the same. Now, 22, before we can start trying to get them to be the same, we need to make sure to factor every single denominator. Yep, that's not good. That'd have been embarrassing. I made the whole hour and not realize that. We're going to move on.
I don't know what it was, but it's funny.
Yep. Now, if the numerators factor with addition and subtraction, we're not going to factor them at all, because there's no point in doing that. If we did factor the numerators, we'd have to undo that and multiply it back out. The ones that we are focused on with addition and subtraction are the denominators. X plus 7 is as simplified as it gets. There's no greatest common factor. The degree is 1, so we're good there. Now, the x squared plus 5x minus 14 is factorable. There is no greatest common factor to factor out. So we'll do our two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. And our factors of 14, 1 and 14, 2 and 7. 2 and 7. Now, for most of these here, we're not going to get completely new factors for this. So it's not going to be x plus 7, x minus 7, and x plus 2. There's going to probably be some commonality. And if we check to make sure, x times negative 2 is negative 2x. 7 times x is plus 7x, giving us positive 5x that we wanted. Because if it had been x minus 7, to get them to be the same, well, they wouldn't share anything in common. It would cause more multiplication. So, and what I mean commonality is the fact that they both already have an x plus 7 in common. Now, we need to get the denominators to be the same. The one on the right has x plus 7, but it's missing in x minus 2. So we're going to multiply on top and bottom x minus 2. Now, is there anything the one on the left doesn't have that the one on the right does? Well, no, right? Because the only thing the one on the right had was x plus 7. The one on the left has it. So we don't have to multiply the one on the left by anything. It's just going to stay the same. So our left rational expression is going to say x squared minus 5. The denominator is still going to be x plus 7, x minus 2. Yes. Now the one on the right, denominator is going to be x plus 7 times x minus 2, which is what we wanted because we want the denominators to be the same. Now the numerator, we're going to multiply through. X times x is x squared. X times negative 2 is negative 2x. Then we're going to do the same thing with 3. 3 times x is plus 3x. And 3 times negative 2 is negative 6. Now, before we start subtracting, we do need to combine like terms. The one on the left doesn't have any like terms, but the one on the right, our negative 2x plus 3x is going to be plus x minus 6. Questions on how we got to this point here? Now, since the denominators are the same, we can subtract the numerators. Now, for this one here, it's going to be good to put the parentheses because we are subtracting, and what we're subtracting this by has more than one term. We're going to have to change or apply that subtraction to every term. Now, the x squared minus 5, signs don't change because the sign in front of it wasn't there. It's a plus, so we're not changing any of the signs with it. But we do have to apply this negative to every term in this set of parentheses here. So our positive x squared becomes negative x squared. Our positive x becomes negative x. And our negative 6 becomes positive. And once we finish applying that minus, we can combine like terms. Now the denominator at this point is going to say x plus 7, x minus 2. Our numerator, x squared minus x squared, well, that is 0. Negative x, well, is just negative x. There are no other like terms with it. And lastly, negative 5 plus 6 is plus 1. And that's our final answer. Questions on this here so far? Pretty good with this here. And luckily on the test, we're not going to have one like 23 where we have three things being added or subtracted. It's mainly going to look like 22. Least common multiple. Least common multiple. We're trying to find the first expression that we can make the given expressions be the same. So we'll look at 26 and 29 for certain. If we do have more time, we can come back to it, or if you need to see the other two, there is also the full video if we run out of time. Okay. With least common multiple, the first thing you need to do is factor them all the way down as far as they possibly can go. Now with 26, 2x squared, that's as simplified as it gets because there's only one term. 4x plus 12. There is no x squared, so we're not doing two sets of parentheses. Is there a greatest common factor? It is 4. We can factor it out, giving us 4 times x plus 3. And it's as factored as it gets. X squared normally tells us we might have to have two sets of parentheses, but do make sure to factor greatest common factor out first. Because if there is a greatest common factor of, say, x, between x squared and 4x, we factor it out, the x squared's gone. We don't need two sets of parentheses. Now that both of them are reduced, we can look at the least common multiple. Well, if I look at the one on the right, it has an x plus 3. Well, that means the x plus 3 has to be included in the least common multiple. It shows up once, we need it at least once. Now, the only other part for the least common multiple for this one here is, well, the 4 and the 2x squared, yes? Well, between both of them, one of them has an x squared, so the least common multiple needs to have in what? X squared. Even if it was 2x squared and 4x, it would still be x squared, because we need at least x twice, so x squared. Now, the last thing is finding the least common multiple between 2 and 4. What's the first number going up that we can turn both 2 and 4 into? Because 8 would work, but it wouldn't be the least. Unfortunately, we can't turn 4 into 6. It's actually kind of, because if I look at the multiples of 2, 2, 4, 6, 8, 10, 12, yes? Multiples of 4 are 4, 8, 6, 12, 16, 20. Yep, but they can both be 4. Least common multiple between 2 and 4 is 4. Yeah. Because it's like, what is the first number? We can multiply both 2 and 4 by another number to get to it. So we multiply 2 by 2 and get 4, and 4 is already 4. Yep. So the least common multiple is this here. If a problem like this did show up, if you'd put, say, 6 or 8, 6 really doesn't work, but 8, instead of saying 4x squared, you had 8x squared, you'd still get the majority of the points, because you just wouldn't get the one for the 8. But, questions on 26. 29. We need to factor each one of these completely before we can find the least common multiple. Well, 4x squared minus 16 has a greatest common factor of 4. And if we factor it out, we're left with 4 times x squared minus 4. X squared minus 4 is a difference of perfect squares. Part of the reason that we have this is if we have an x squared and a number being subtracted, what times itself is x squared? X and x. Is there a number times itself that gives us 4? 2. So we have x plus 2 and x minus 2. And if you're not sure if we can multiply a number by itself, take the square root of it. Square root of 4 is 2. So 2 is our number. Let's look at the other one. 6x squared minus 24x plus 24. Is there a greatest common factor between these three terms? 6. And if we factor it out, divide it out of each term, we're left with 6 times x squared minus 4x plus 4. Now, when we factor this here, since the third term is positive, our signs are the same and match the sign in the middle term. Minus and minus. Factors of x squared are x and x. Now, our factors of 4 are 1 and 4 or 2 and 2. Here we actually want 2 and 2. If I did check this, x times negative 2 would be negative 2x. Negative 2 times x is negative 2x, giving us a middle term of negative 4x. So that is the middle term we wanted. Because it seems like it should be 24x. But since we divided that 6 out, we're looking at 4x, not 6x. Negative 4x. What questions on this here? And with any of these here, I would start with our factors first. The one on the left has an x plus 2. It has it once. How many times does the one on the right have it? 0. So how many times do we need it? Once. Since it showed up once, we need it at least once. Let's look at the other one on the left, x minus 2. The one on the left has it once. The one on the right has it twice. So how many times do we need it? Twice. Whichever one has it the most. And again, if you can get at least here, you've gotten pretty much all the points. The only thing we have to do now is find the least common multiple between 4 and 6. First number we can turn both 4 and 6 into. Unlike the first one, it's not 6. 12. Because if we look at the factors of 4 and the factors of 6, 12 is the first number we can turn them both into. I mean, we can also do 24, 30, not 30, but we can keep going on from there, but 12. So the least common multiple for this here is 12 times x plus 2 times x minus 2 times x minus 2. And that's it. Questions on this here? We're ready for solving. I'm going to skip to 34 because 31, 32, and 33, there's not problems exactly like this on the test. We're going to be looking more at equations. like 34 through 39. Now, when we went through this chapter in 3.5, or not 3, 7.52, we had restrictions. We had problems with the restrictions. And on the test, it will specifically state in the instructions, beware of restrictions, or restrictions might show up. Because if it says that, we need to list the restrictions. If it doesn't, you don't need to worry about them. So I'm giving you guys that ahead of time so you're not having to work through the restrictions if they're not needed. So we look at 34. The first thing we do before we find the restrictions, if they're going to show up, or start solving, is we need to factor every denominator. X plus 1 doesn't factor. But our x squared minus 1 does. And it factors 2. X plus 1 and x minus 1 is a difference of perfect squares. Questions on this here? Now for this one here, the restrictions aren't going to show up, but I'm going to go on and act like they are. Because if they do, we take each of our denominator expressions, x plus 1 and x minus 1. We set them equal to 0 and solve. So for x plus 1, we would minus 1, telling us that if x is equal to negative 1, that expression would be 0. So x cannot be negative 1. For our x minus 1, we would add 1, telling us if x is positive 1, one of the denominators would be 0, so x cannot be 1. So if x is 1 or negative 1, we would have a restriction and it wouldn't work. Questions on this here? Now, what do we need to multiply the whole thing by to solve? Well, x plus 1 and x minus 1. In our far left one, the x plus 1 and x plus 1 would cancel. In the middle, we would have the x plus 1 and x plus 1, and x minus 1 and x minus 1. Now, since the 3 does not have a denominator, nothing simplifies. And what that leaves us with is 4x plus 1 times x minus 1 is equal to, well, the 12, our middle expression, everything simplified, plus 3 times x plus 1 times x minus 1. Questions on this point here? At this point, we need to start factoring, not factoring, distributing. 4x times x, 4x squared. 4x times negative 1 is negative 4x. 1 times x is plus x. And 1 times negative 1 is negative 1. Equals 12 plus 3 times, well, our first set that we just distributed, since there's not a number or sign in front of it, a minus sign specifically, we don't need parentheses around it. But since our x plus 1 and x minus 1 still have the 3 out front, we have to leave that parenthesis there for now. Now when we distribute, x times x is x squared. X times negative 1 is negative x. 1 times x is plus x, and 1 times negative 1 is negative 1. Now at this point here, we can combine like terms. Our negative 4x plus x is negative 3x minus 1 equals 12 plus 3 times, well, negative x plus x is 0, giving us x squared minus 1. Now, before we can do anything else, well, we've got to distribute one more time. We have to distribute that 3 through the x squared minus 1 to finish that out. Questions on this here? We good? Now, we do need to combine like terms one more time, because we didn't have any like terms till we had to distribute, because our negative 3 and 12 are like terms. Negative, or 12 minus 3 will give us plus 9. And at this point here, because we have an x squared term, we need to get this equal to 0. So we would subtract 3x squared from both sides. Our 3x squared minus 3x squared is 0. 4x squared minus 3x squared is x squared. Telling us that we have x squared minus 3x minus 1. We haven't got it quite equal to 0, so we can subtract 9. Telling us x squared minus 3x minus 10 is equal to 0. Questions on how we got to this point here? Huh? Thursday? I don't know. I don't think so, because we still have academic practice that night. I will see, because I'll have to figure out, I haven't planned that far ahead. Now, here, x squared minus 3x minus 10. If the number in front of x squared, when we're solving these, is 1, I would suggest go on and graphing it. 3x. Because again, when we graph it, we're looking for what values of x make the y value be 0. And those x values are negative 2 and 5. So here x is equal to negative 2, and x is equal to 5. So at that point, I would graph it. Is either one of those our restrictions? No. So those are our two solutions. There's only one of the solving problems on the test that you can't graph at the end and get the answer. Any other questions on this here? Yes. We can look at 35 next. Now our restrictions, there's only two places that x appears in the denominator. And that's with 3x and, well, 3x. So we can set 3x equal to 0. Divide both sides by 3, telling us that if x is 0, the denominators would be 0, so x cannot be 0. Now we can see what we need to multiply everything by. As we do know for sure, we're going to need to multiply everything by x. What else would we need to multiply everything by? Because we're trying to make the 6 and 3 simplify out, yes? So we can multiply by 3. Since here our 3x and 3x would cancel. On the far right, the 3x and 3x would cancel, yes? And will the 3 and 6 simplify here? Because 3 over 6, because here we would have 2 times x because everything canceled, plus we would have x, but 3 over 6 reduces to 1 over 2. That shouldn't be 2x, that should just be x. 2 over x is equal to 4. So did all of our denominators simplify? Well, no. The middle one is still 2, yes? So we have to actually multiply everything also by another 2. Because what we needed to multiply everything by, the least common multiple for this here was 6x. So if we do multiply it by 2, our 2 times 2 is 4. Here the 2's finally cancel. Do we have an x squared term? Do we have an x squared? Mm-hmm. No, so get x by itself. That's it. And since that's not one of our restrictions, that's the solution. That's it. Questions on this here? Let's look at 38. We're going to look at problem number 38. That needs to be negative. And again, before we solve, we need to factor every single denominator, be that factoring out a greatest common factor or 2 sets of parentheses or both. If one of the denominators is factorable, we have to factor it before we find restrictions or start solving. Because here our x squared plus x minus 6 is factorable. We'll have 2 sets of parentheses. Now there is no greatest common factor, so we're not factoring it out. But since we do have 2 sets of parentheses, our third term is negative, so the signs are opposite. The only factors of x squared are x and x. Now the factors of 6 are 1 and 6 or 2 and 3. We're going to use 2 and 3. And I can check it here. We would check it off to the side. X times negative 2 would be negative 2x. 3 times x would be plus 3x, giving us the positive x middle term that we wanted. Questions on how we got it factored? Now our restrictions, there are 3 spots where it could be 0, but one of them is x plus 3, and the other is x minus 2. Now for our x plus 3, to solve it, we would subtract 3 from both sides, telling us x is equal to negative 3, so x cannot be negative 3. For x minus 2, we would add 2 to both sides, telling us x cannot be 2. So those are the restrictions we need to be looking out for. Now at this point here, we can start solving. So we're going to have to multiply the whole equation by x plus 3 and x minus 2. Now the one on the far left, the x plus 3 and x plus 3 would cancel. The x minus 2 and x minus 2 would cancel. Our middle term, the 2, nothing's going to cancel. But on our far right, the x minus 2 and x minus 2 would cancel. And what that leaves us with is, well, negative 5 is equal to 2 times x plus 3 times x minus 2 plus x minus 3 times x plus 3. Negative 5. Now we're going to have to multiply our x plus 3 and x minus 2 first. So we can distribute the x. X times x is x squared. X times negative 2 is negative 2x. 3 times x is plus 3x. And 3 times negative 2 is negative 6. Now our x plus 3 times x minus 3, since there's not a number in front of the parentheses, and the sign in front of it is plus, we don't need the parentheses when we do the multiplication. X times x is x squared. X times 3 is plus 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. Now, before we do any multiplications with the 2, it's going to be helpful to combine like terms inside the parentheses here, giving us x squared plus x minus 6, because our negative 2x, plus 3x would be just positive 1x. Outside the parentheses, our 3x and negative 3x is 0, leaving us with x squared minus 9. Questions on how we got to this point here? Now, the next thing we can do before we solve is to distribute the 2. 2 times x squared is 2x squared. 2 times x is plus 2x. And 2 times negative 6 is negative 12. Before we can start solving, we do have like terms. 2x squared and x squared is 3x squared. Our x term does not have any like terms, but our negative 12 and negative 9 are like terms. Negative 12 minus 9 would give us negative 21. Do we have any other like terms? No. But since we do have an x squared term, we need to get this equal to 0. So we're going to add 5 to both sides. And when we add 5 to both sides, we get 3x squared plus 2x minus 16. And that whole thing is equal to 0. Now, there will be one problem similar to at least when we get to this here, where the number in front of x squared is not 1. If we have that, we have to factor. We could graph this, and most likely it'll give us one solution. It won't give us both. It'll only give us one. So it's going to be helpful to factor. But I would also check for greatest common factor before we do that. But 3x squared, 2x, and negative 16 don't have one, so we're going to have to factor. Since the third term is negative, our signs are opposite. Factors of 3x squared, well, we would have x and x, 3 and 1. Factors of 16, 1 and 16, 2 and 8, 4 and 4. And we can go through the possibility of checking all these here. But I'm going to start off with 8 and 2. Now we can check this here to make sure. 3x times negative 2 would be negative 6x. 8 times x would be plus 8x, giving us a positive 2x. So that's the middle term we wanted. Questions on how we got to this here or got it factored? Whenever we have it factored, whenever we have two things multiplied together to equal 0, one of these two expressions is going to have to be 0. Either 3x plus 8 is going to be 0 or x minus 2. Now we just solve for x. So we would subtract 8 from both sides, telling us 3x equals negative 8. Divide by 3, telling us x is equal to negative 8/3. Our other side, x minus 2, we would add 2, telling us x is equal to 2. Is either one of these a restriction? What were our restrictions? Negative 3 and 2. Since 2 is a restriction, we just cross it out. It's an extraneous solution. It's a solution we get from solving, but does not work in the original equation. Yes. Any other questions on any of these here? We have time for one more. Which one do you want to do? 37 or 39? 39. With 39, the first thing we're going to have to do is factor the denominators. I'm not going to belabor the point too much, but we'd go through and factor them. And when we factor these three denominators, the first one would be x plus 2 times x minus 1. The middle would be x plus 2 times x plus 1. And the last one would be x plus 1 and x minus 1. Now, our three restrictions for this here are going to be these here. X plus 2, x minus 1, x plus 1. For x plus 2, the value of x cannot be negative 2. For x minus 1, the value of x cannot be positive 1. And for x plus 1, the value of x cannot be negative 1. So if we get one of these three solutions, it does not work. And we're going to have to multiply the whole thing by x plus 2, x minus 1, and x plus 1. And interestingly enough, this actually simplifies a lot nicer than we think. Because the far left, x plus 2 and x plus 2 cancel. X minus 1 cancels. The middle, x plus 2, x plus 2, x plus 1, x plus 1. And our last one, x plus 1, x plus 1, x minus 1, x minus 1. Leaving us with x times x plus 1 is equal to x times x minus 1 minus x times x plus 2, which is kind of nice. Because when we distribute this here, x times x is x squared. X times 1 is plus x equals. Here, x times x is x squared. X times negative 1 is negative x. Here, we're going to distribute the negative x. Negative x times x squared is negative x times x is negative x squared. Negative x times 2 is negative 2x. Now, even though we do have an x squared, we do want to combine like terms before we move everything to one side. Well, x squared minus x squared is 0. Negative x minus 2x is negative 3x. Now we still have an x squared term, so we need to get it equal to 0. So we can add 3x to both sides. Minus x squared plus 4x is equal to 0. Now since the number in front of x squared is 1, we don't have a number written in front of x squared, we can graph this and say x squared plus 4x. Graph. We see that it hits the x-axis in two nice spots. Second table. And again, we're looking for the values of x that make the y value be 0, which are negative 4 and 0. Are either one of those our restrictions? No, so both of them work. Now, since we do have a little bit of time, I can go on and factor this. Is there a greatest common factor between x squared and 4x? It is x. And we could factor it out, leaving us with x times x plus 4. Since we have two things multiplied together to equal 0, one of them must be 0. Well, so it says x is 0. Our x plus 4, we would minus 4 from both sides. Minus x is also negative 4. So we did find those by graphing. But either way, we get these two here. Any other questions on this or the review sheet? Well, if you do have questions, please let me know.